We gaze into the infinite cosmos, mapping galaxies millions of light years away, yet we remain strangers to the world beneath our feet. While our telescopes peer across the universe, the enigmatic realm below Earth's crust, a mere few kilometers down, is less known to us than the surface of Mars. This episode journeys not outward but inward to explore the hidden engine of our own planet, the deep and layered sources of Earth's internal heat. The Earth is a dynamic planet. Its surface shaped by earthquakes, volcanoes, and the relentless drift of tectonic plates. This vibrant activity is merely the surface expression of a deep and powerful internal engine driven by heat. The sources of this heat are not uniform. They are a layered tapestry of primordial energy, nuclear decay, and ongoing physical transformation, each contributing differently to the planet's thermal budget and defining the very state of Earth's interior. The state of Earth's layers, solid, liquid, or plastic, is a direct consequence of a delicate balance between heat and pressure. The inner core, a solid ball of iron-nickel alloy, exists at a staggering 5,500 degrees Celsius. It remains solid solely due to the immense pressure from the weight of the entire planet above it, which raises its melting point astronomically. Conversely, the outer core is liquid because the pressure, while still immense, is insufficient to prevent melting at those slightly lower temperatures. The mantle is almost entirely solid, yet it behaves like a plastic over geological timescales, convecting and flowing due to the intense heat and pressure. Finally, the crust is a rigid, brittle shell. Its relatively cool temperature and low pressure allowing it to fracture and shift. The contribution of internal energy to Earth's heat flow is highly stratified by layer. Think of the Earth's core as a giant superhot battery. It stores most of the planet's original heat left over from when the Earth first formed. This ancient heat slowly leaks out and is actually responsible for 15 to 30% of the warmth we feel coming from the ground. This relentless heat loss means our planet has been cooling since its birth, a process that will continue far into the future. The Earth's internal heat comes from two main sources: primordial heat left over from the planetary formation and radiogenic heat from the decay of isotopes. While the core is hot, it produces negligible new radiogenic heat. Nearly all radiogenic heat is generated in the crust and mantle by the decay of elements like uranium-238, thorium-232, and potassium-40. This radiogenic heating is the dominant source, accounting for most of the heat reaching the surface. The crust is highly enriched in these heat-producing elements, but the mantle's immense volume makes it the largest overall contributor. This uneven distribution is a direct result of planetary differentiation. The key radioactive elements are lithophile, meaning they have a chemical affinity for silicate minerals. During Earth's formation, they were therefore sequestered in the rocky outer layers, the crust and mantle, while being excluded from the metallic core. Consequently, the crust has the richest pockets of radioactive elements. But because the mantle is so enormous, it contains more of them overall, making it Earth's main source of radiogenic heat. In conclusion, Earth's internal heat is a multifaceted legacy. The solid inner core and liquid outer core stand as a testament to the primordial forces of accretion and gravity, their stored energy slowly seeping out over billions of years. The solid yet flowing mantle and brittle crust, meanwhile, are powered by the steady, invisible fire of nuclear decay. This partnership between the core's ancient furnace and the mantle's nuclear reactions is what powers the great conveyor belts of rock that reshape our planet. This complex engine not only fuels the geology we see, but also generates the magnetic field that shields us, making Earth a living, breathing planet in the vastness of space. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.